to find it in real units. For u equals 2 meters per second and m equals 0.6 meters per square per second. It's important to realize that 0.3 meters per second is really m over 2, because we're only looking at one half of the picture. Imagine that there could be a mirror image here from the bottom, where there would be suction at this point from the bottom stream, so the total strength of that sink is 0.6 meters per square, and that's what we have to use. So now RA is 0.6 meters squared per second, or 2 pi times 2, and when you work it all out is 0.0477 meters. So it's about 5 centimeters past the point where we have the stagnation point. Now, to find the height h, the streamline that represents basically the division of fluid that is being sucked into, we essentially declare this streamline passing through A to be the zero streamline, and look the position of that streamline for if we go back to infinity. For this infinity here, angle theta is really pi, because this is theta equals 0, this is theta equal pi. So we have that streamline. We're looking at the expression for the stream function in its entirety. Basically we're saying that u r sine theta minus m over 2 pi theta equals 0, or the equation for the streamline is that r sine theta equals m over 2 pi u times theta. So this is the equation for the entire streamline that passes through this point. I can even write it here basically. R sine theta equals m over 2 pi u times theta. And we're looking at the position at the height of that streamline for theta equals pi. So for theta equals now here we have expression for r, but what I really want to find out is the height h. So I need to convert this really, at least this expression, into x and y coordinates, and from basically saying that conversion that x is equal r cosine theta and y is equal r sine theta. So this is nothing else but my vertical coordinate y. So in other words, I have the expression y equals m over 2 pi u times theta. And you can see sometimes it's convenient, we can use mixed coordinates where we have retained angular theta here, and we have Cartesian coordinate tie. So for theta tending to pi, then y becomes that height h. In other words, h is equal m over 2 pi u, because over 2u, m pi, sorry, over 2 pi u, which is equal to m over 2u. And we can substitute the actual units. 2 times 2 meters per second, which is 0.15 meters. So we can also check the fact that the total flow rate for this height has to be equal to the sink here. And given that this is uniform flow here at 2 meters per second, we can say that h times u must be equal to m half, because that's the strain. And so this is just to check. So we have 0.15 meters times 2 meters per second is indeed equals to 0.3 meters squares per second. So, but the actual solution is 0.15 meters per second.